Hey everyone. So first, a little bit about myself. I'm from Scotland. I have 9 pets. If you don't know what a chinchilla is or a daegu, I've got loads of photos. Come and speak to me. I'm a lover of esoteric programming languages. Has anyone heard of Ponylang? No. All right, one person. Okay, cool. So yeah, I like to play with random programming languages. Currently, my favorite language is Rust. It seems like the whole world seems to be going that way. So if anyone wants to talk about weird and random programming languages, again, come and speak to me. I'm on the Kubernetes release team, so I like to do a lot of things with Kubernetes. If anyone wants to talk Kubernetes, again, I'm here all day. So, and I'm a stoic, so I take things as they come. I think too much, and I do a lot of meditations. I consider myself quite a pragmatic person, quite a patient person. So, as far as my job, I'm a developer advocate for a company called InfluxDB. Has anyone heard of them? Cool. So we're going to do the boring show of hands bit. Who's using InfluxDB? Sweet. Who's using Telegraf? All right, okay, so about half the room maybe. So for those that aren't familiar with Telegraf, we're going to take a quick look at it just now, because I always like to start my talk with a demo. So let's just create a temp directory, fire this up. So Telegraf is an agent. It collects metrics from a variety of sources and stores them in your time series database of choice. Now, what's really nice about InfluxDB is that everything the company does is open source. You don't have to use InfluxDB to use Telegraf. If you want to use Prometheus, that's fine. If you're using Nagios, Asinga, Cassandra, it doesn't really matter what the backend is. Telegraf probably supports a plugin that allows you to write to it. So we like to think that we are part of a very inclusive and open monitoring landscape, and we don't necessarily want to force you to use InfluxDB if you don't want to. So Telegraf is really cool, and that's what I want you to walk away from this talk with. So it uses TOML for its configuration. That's going to be far too small, right? Is that okay? Someone at the back, thumbs up? Not the front, come on. So there are a whole bunch of plugins. There are over 200. I'll kind of cover some of them today. But essentially, you write something like this. So this is TOML that says activate the memory input plugin. I can also use the disk.io plugin. We save that file. Where's my terminal? And we point it to our conf. Oh, I need an output. So I'm just going to write all my metrics to standard out, like so. That loads the config. You can see that it's enabling my input plugins here. So I've got memory and disk.io. We're not using any aggregators or processors. I'm not even going to speak about them for the majority of this talk. And we're using an output of file. Now we have a flush interval here of 10 seconds, which means it's going to write the metrics to standard out. Now, there we go, perfect timing. So this is what we call line protocol. It's just a language for describing metrics. It's not similar, but close enough to the open metrics exposition format in that we have the same concept of tags. What's different from line protocol is that every point can have multiple fields. So where with open metrics exposition format, there's only one value per metric. Things are a little bit different in InfluxDB. But we do have first-class support for that format as well. So even if you are using Prometheus, Telegraf works very nicely with it. And that's it. It's a single binary. It fetches metrics, and it puts them somewhere. This is the most simplest example we can do because we're writing to standard out. So hopefully now we're all on the same page with regards to what Telegraf is and the problem it's trying to solve. So now what I want to do is take you on a journey and kind of show you why it's very, very cool. So Telegraf is plugin based, so there are plugins for everything. At the moment, there are over 200 plugins, and this grows pretty much weekly. With regards to the inputs, so an input plugin in Telegraf is something that Telegraf can go and speak to fetch metrics. We have currently over 169 of them. So it doesn't really matter what you're running in your infrastructure, whether it be HBase, Cassandra, MongoDB, Postgres, Rabbit, anything. The chances are there is a plugin that can get the metrics out of that system. We support over 35 output plugins. So again, it doesn't matter if you're not using InfluxDB. You can write to whatever data store you want to use. In fact, you can write to multiple, which is something we're going to focus on in this talk as well. Telegraf has a concept of a processor, parser, serializer, and aggregator. These allow you to do in-memory transformations and aggregations of your metrics as they come in, so that you can reduce the cardinality or even just reduce the retention or the, if you're scraping at 10 seconds, maybe you want to aggregate that to 1 minute before you ship it to your database to reduce the cost. All of this can be done in memory with Telegraf with a few lines of TOML. So very, very powerful tool. It's a very fast-moving project as well. So I'm going to take a look at the last 3 releases. We had 1.10 in May, and you can see that we add inputs pretty frequently. So over half a dozen inputs being added here. There was a big push from the Google team to make sure Telegraf was a first-class citizen in GCP, which is why the PubSub and the Stackdriver stuff is here as well. Outputs, again, you can write to anywhere. Kafka's a really popular one. We're going to talk about that today. I'm assuming most people here have some sort of Kafka cluster or moving towards using Kafka in their infrastructure. So Telegraf has really good integrations there. A couple of months later, we released 1.11. Again, you're going to see a theme here that we're always adding new inputs. Right? We always want to make sure that Telegraf supports whatever software you're using, and we can get useful metrics out of that system. We had a couple new outputs, serializers, aggregators. Right? The theme here is very simple. Every time we give you a new version, we're always adding new stuff. What's really cool is that a lot of this isn't done by people that work at InfluxDB. So Telegraf is our most successful project. And when I define successful, I mean that it has more open source contributors than any other product at InfluxDB. That's because it is really, really easy to contribute to Telegraf. So if you are curious of how you can do that, please find some time and we can speak about that later today as well. But you can write under 50 lines of code for an input plugin and start scraping metrics immediately. So there is a problem with being an open source company, right? Now that we have 200 plugins as part of the Telegraf ecosystem, that's 200 plugins that we have to maintain. And the challenge there is we don't know who's using which plugin, like at all. There is no telemetry in Telegraf whatsoever. So there's no way for us to know if we're wasting a lot of time and effort maintaining older plugins that nobody is actually using. So this got me thinking, is there something here I can do? Is there anything I can scrape from the web to try and work out at least by an indication of what plugins are being consumed? So I had an idea. I went on to GitHub, I did a file search, and I found 3,249 telegraf.confs. So that was a starting point. Now, I had a bit of a problem. The GitHub API is frustrating. And you can actually only get 1,000 results back per request. And because of the nature of my search, I was trying to download everything. There was no way for me to configure offsets or pages or anything like that to get more. But I work for a time series company, so I'm just going to call it a sample. So I grabbed 1,000 telegraf.confs, and I began to analyze them to try and get an understanding of what plugins people are using. Now, there are a few things to note here. Obviously, a lot of people commit the default configuration, so that's not very useful. These are only open source telegraf.confs, so they're not probably truly representative of what people are actually doing. But it's the best I've got. So people are using Telegraf to write to InfluxDB, over 72%. That's expected, I would imagine. 5% are writing to files, 2% are writing to Prometheus, and then really nominal access to anything else after that. This was kind of shocking. I expected the Kafka number to be a lot higher, but that's fine. There was no surprising things here with the output plugin. So I wanted to try and understand how many of the telegraf.confs were the default settings. So I started to look at some of the configuration options that are available to us within Telegraf. Now, the first one is interval. How often do we want to go and scrape the metrics? 10 seconds is the default. This number correlates back to InfluxDB's output of 72%. So there is a high chance there is some default configuration fails, or at least people aren't tweaking them too much. A few people are using 1 second, and then so far, if you can see, there's very limited distribution of the collection interval here. What was surprising to me was people generally adopt InfluxDB when they want high-resolution data. Right? InfluxDB is the only time series database, I believe, that supports nanosecond resolution. But there was nothing even less than a second. So Is anyone doing high-resolution scraping of metrics? No financial traders? No? All right. There's another option in Telegraf called the round interval. This is probably the question I get the most when people find out I'm talking about Telegraf, like, what is it? And it's really, really simple, so I'm just going to take 5 seconds to explain it. But when you run Telegraf with a scrape interval of 10 seconds, it doesn't necessarily collect or scrape any metrics within the first 10 seconds. It might actually wait the 10 seconds. What a lot of people like to do is actually collect on the clock. So at 10 seconds passed, 20 seconds passed, 30 seconds passed, rather than it being 10 seconds from the time they start the daemon. That's all the round interval does. If you set it to run on the hour or have a 60-minute round interval, it will run on the hour every hour and stuff like that. So the round interval is useful if you just want to, kind of group metrics together or make the windows predictable for query time. The jitter, again, 90% of people aren't using this option. If you have a high number of inputs and you're collecting a lot of metrics in memory or you want to write to multiple databases, the jitter just means it's going to add on an arbitrary number to that interval so that you're not hitting the database or all the same systems at the exact same time. Most people aren't using that, though. The hostname is an interesting one for me because I'm a Kubernetes person and a container person. So the fact that anyone would ever write a metric with a hostname on it confuses me. Like, it's really not that important. Bare metal setups, of course, but as the industry moves towards containers, I expected this to be a lot higher. But 90% of people are not turning this on, which means 90% of people are writing their metrics with a hostname in it. If that's a container ID, your cardinality is going to explode. So there's definitely something to be mindful there. If you are in a container or Kubernetes environment, definitely use that setting. So of the output plugins, most people are just writing to a single source, probably InfluxDB, based on what we've seen. 5% are writing to multiples, that's good. Writing to multiple outputs is important for metric collection. You want a pipeline you can trust. The only way to build trust is to correlate the numbers from one output and another output and check. Otherwise, you have no idea if you're missing metrics. So if you aren't writing to multiple sources, that's a really good take home here today. Write your metrics to more than one place. There is a cost, but you don't need to keep the metrics for long. Even if you only store them in the second data store for an hour or 6 hours, it still gives you enough of a window to make sure your metric collection is correct. Now this is where things got a little bit more distributed. So a lot of people are using any arbitrary number of input plugins. But the one person with 56 input plugins, I have no idea what the hell they were doing. I'm not even sure Telegraf would perform well at 56 inputs. That's probably going to be quite intensive, depending on what the inputs are. If they're 56 HTTP metric-based systems, yeah, that's not going to work. Of the input plugins that are being used, there were absolutely no surprises here whatsoever. People are doing system Linux-based monitoring. They want to know the CPU, memory, disk, et cetera, et cetera, et cetera. This is the easiest way to get started with Telegraf, so of course, the distribution here was going to be quite high. Now, we do have 28% of the people are using the Docker input, but 90% of the people that are not emitting the host name, so there are a lot of people out there that are going to have very high cardinality in their TSDB. So I kind of hammered this home twice now, hopefully, right? But really seriously, write to multiple outputs. And I want to show you how easy that is. This is the TOML configuration again, where I'm specifying that I want to write to InfluxDB1 and I want to write to InfluxDB2. Who's brave and running the alpha of InfluxDB2? All right, I can be your support channel for the next 24 hours if you want. Have you had any problems with it? Good, awesome. So InfluxDB2 is currently in alpha 19. It will be approaching beta very soon. We're trying to encourage as many people to try that out as possible. I'll talk about that later. But you can write to multiple outputs, right? So all it takes is 4 lines of TOML, and I can write my metrics to multiple places. Again, this doesn't have to be InfluxDB. It can be Prometheus, it can be Cassandra, it can be Elasticsearch, it can be Kafka. That's up to you. Yeah, of course, go for it. Can we get the mic? Feel free to interrupt me as we go. I'm happy to take questions.
Okay, is there a way to load balance the output from a single output to multiple input provider? So I have a DM set and want a gateway host. And for load balance and high availability, I have two gateways. So I want to load balance between both. Is there a way to configure the system so?
Yes, so I mean, if you're using like an HTTP output or something like that, or some of the outputs will support multiple URIs or IP addresses, which will be load balanced. But there are caveats there, in that if they are, sometimes they can be long-running connections, like a service output, in which case there's other things you have to do to make that work. It gets a little bit complicated, but I'll speak to you after the talk, and you can tell me what outputs you're using. But there are ways to do it.
Right, thanks.
So any more questions on that? Cool, right. So Telegraf, as of recently, added a really cool feature for remote configuration. That means that you don't actually need to distribute telegraf.conf everywhere anymore. It can load it from any HTTP path or file system path. Really simple to use, right? It's the exact same config parameter, only we're going to pass in some sort of HTTP URI. What I do now is, I'm trying to make sure everything that I do is now committed to Git. So I'm using the GitHub user content, the kind of, that way of getting the raw data over the HTTP API, and I keep everything inside of Git. So I can just tell Telegraf to go fetch that file, parse the config, and run.
It's stored then locally?
Yes. But you can configure it to reload that. Telegraf has a really cool feature where you send a SIG up, and it will reload the config, and that will include refetching it from a remote location. Not a lot of people know that, but it's a really cool feature. So yeah, first, make sure your telegraf.conf is in Git. Right? Hopefully everyone's doing that. The only change to your flow here is if you're using Puppet or Chef to then put that onto machines. You then, every time you change it, you have to re-trigger that manifest or cookbook or whatever. This is actually a lot easier, and you can use the SIG hub to force the reload. What I would suggest, and hopefully nobody is doing this, is obviously don't commit secrets. Telegraf.conf does have access to passwords and usernames and remote URIs for their outputs. So Telegraf does support bash-style interpolation of the config. So all you need to do is make sure the environment variable exists when you run the Telegraf command, and it will interpolate that into the file. You can also use it for non-secret stuff. So I like to keep my telegraf.confs pretty generic so that I can tweak them at runtime. Things like it's really good being able to use your interval as an interpolated variable, because it means that if something is going wrong, then I don't need to do an entire Chef or Puppet thing. I can just go onto the machine and then restart it, passing in a different interval collection. So there are lots of cool perks to using that. Now, I always talk about monitoring pipelines and making sure that they're correct. And one of the things I want to talk about is just resiliency. So again, when I was looking at all these telegraf.confs on GitHub, I realized that not a lot of people are tweaking or even using the metric buffer. Does anyone know what the metric buffer is? Right, 3 hands. So the metric buffer is a really cool way, and that Telegraf, if it cannot reach your output, it will keep those metrics in memory till the size of your buffer limit. So let's assume we have Telegraf writing to InfluxDB1, InfluxDB2. Your InfluxDB2 is down because you're restarting it, you're deploying a new update, whatever that is. There's going to be 2 or 3 minutes where it's unavailable. Telegraf can cache all of those metrics, and it's per output, so keep that in mind. It'll keep all of those in memory until it comes back online, and then flush them all back down the pipe. So the plan being, you should never lose a metric. You can set the buffer limit to whatever you want. Its default is 10,000, I think. So that means 10,000 metrics per output will be held in memory. If you have a large amount of RAM in your system, you can obviously increase that. It really depends on what kind of resiliency and what failure scenarios you want to kind of support. So let's take a look at this is the Telegraf architecture V1, right? This is what most people start off with. They have Telegraf running. It is fetching metrics from the network, from bare metal, from VMs, and any software dependencies like Kafka, etc. We can use the buffer, which we've just talked about. Another really cool thing that Telegraf offers is the ability to batch, right? Now, that means that if you're collecting a high velocity of metrics, 10,000, 20,000, 100,000 per second, you can batch them up into groups of 50,000, 200,000, etc. So you're reducing the amount of requests over the network. That writes to InfluxDB, but what everyone does initially is has their application, if it's instrumented with Influx, write directly to Influx. And that's usually a problem. Again, if Influx becomes unavailable, those metrics you're pushing to InfluxDB over the wire are going to get lost. So InfluxDB goes away, metrics go bye-bye. This is what you actually want to do. Now, Telegraf has this buffer and batching ability, so we should use that all the time. And the best way to do that is through one of our input plugins. So Telegraf has an InfluxDB listener plugin and an HTTP listener plugin, which just means that you can use the same InfluxDB client libraries that you're already using, but have them write to something on localhost, so it's just then proxied, batched, and buffered before it hits the TSDB. The thing to note about the InfluxDB listener is it only supports the write endpoint. So depending on the usage of your instrumentation, if you're creating buckets, databases, anything like that, they won't be supported. The commands will just return over 200 OK. So you won't even know anything's wrong, which is good, but you won't actually be executing those commands. So just keep that in mind. But if you're just sending points over the wire, really, really good plugin. Telegraf always tries to keep things config-free as often as possible. The only thing you need to specify here is the device that you want to listen over and the port number. So here I'm just saying listen on all devices on port 8086. And that means my application can now write to localhost on that port as if it was InfluxDB, even though it's getting proxied through Telegraf. There was a really cool, happy side effect from this plugin. As I said at the start, we're currently on a very large migration of InfluxDB 1 to InfluxDB 2. Using the InfluxDB listener, you can continue to use the instrumentation you've already built for InfluxDB 1 while testing InfluxDB 2. So that was pretty cool. What I would add on client libraries is that we're starting to take them a bit more seriously now with InfluxDB 2, and that we're going to start supporting most of the popular languages within the company rather than relying on external support. So if you're looking for a client library for V2, come and speak to me. It's good to get an idea of what languages people are working on. There's a slightly more generic HTTP listener, which will allow you to take any metric over any HTTP client. So even if you don't have a client library for V1 for your esoteric language, then you can just use any HTTP client to write metrics through Telegraf. Very simple configuration again. We pick a port, we tell it what to use, the data format. Telegraf supports open metrics, it supports JSON, CSV, line protocol, graphite, statsd. Again, we support as many things as we can. Now, because InfluxDB has a concept of tags, you have to be able to just specify the fields in the JSON payload that you wish to be indexed. So it's just a tags key array, and we just specify anything that should be a tag rather than a field. That's pretty much the only configuration you need to do. There's going to be a demo of this towards the end where I kind of cover a lot of this. So hopefully when you see it in action, it'll make a bit more sense as well. Now, I've been with Influx Data for 11 months now, and I come from a Kubernetes background. And every time I looked at the Telegraf binary size, I kind of, a little bit. It grows every release, usually quite substantially. The problem is, the more input plugins we write, the more systems we support, they all come with their own dependencies of how we interact with them. So this plugin architecture comes at quite a hefty cost, especially with it being a Go program, because we're compiling everything into a single binary. So the Docker image for Telegraf is currently sitting at 254 meg. It's not huge, but it's bigger than I would be willing to accept. Especially if you have a large fleet and you're shipping this across many nodes. You know, it's just a lot of network bandwidth, especially if you're on AWS where you pay for bandwidth in and out. So I started a project called Bring Your Own Telegraf, and the entire concept of the project was to give people some tooling that they can build their own Telegraf Docker image with only the plugins that they need. So the first build I did, I managed to get my Telegraf under 16 meg. Quite a large difference. So what does it look like? Well, it's a Docker file. It uses the on-build instructions a lot to defer all of the logic so that you don't have to worry about it. So all you have to do is first say use raw code Telegraf BYO, which is just my image that's on GitHub. You don't need any more instructions than that. The build all happens behind the scenes. It clones the Telegraf repository at the version that you want. It scans your telegraf.conf, it works out which plugins are being used, and then compiles a custom binary. We need a second layer, so this is multi-stage builds if you're not familiar, but you can have multiple FRAMs. We're then using an Alpine base layer. We're pulling in the configuration from the build, and then we're pulling in the binary that was custom built for us as well. We just set the entry point to be bin Telegraf, and we now have an image that is custom built with only the plugins we need. So I'm going to click on a few things. So this is the on-build instruction. This is the base layer. It just pulls down dep and make. We are in the process of switching to Go modules on Telegraf. It's been a little bit painful, but support for that should land soon. We copy in my gen code. This is just some Go code I wrote to parts of Telegraf configuration. We make sure that someone specifies the Telegraf version. We clone the repository. We use a depth of 1 to try and minimize the network traffic. And then we build the project. Oops. So this is the exact same Docker file that I just showed you. But what I want to say here in this example repository is that we are trying to make sure you commit everything to Git. So you just have this Telegraf directory inside of Git, we have your conf, and that's it. That's all you need to provide. So this will build it with the inputs CPU, memory, system, and the ability to write to the InfluxDB. Now, obviously, everything here is hard-coded. I could use interpolation, but the example didn't really need it. And one more thing to share, assuming the Wi-Fi holds up. Right. So I got very curious. Were there any other benefits to using the BYO Telegraf over the standard Telegraf? Now, what we have here, I can't really zoom in on this, but hopefully it's kind of understandable. The blue line is the original Telegraf and is the number of bytes allocated on a heap. The purple one is the BYO, so it's substantially less memory intensive. In fact, the normal Telegraf has 8 million bytes allocated. The BYO has 2 million bytes allocated. So it's a quarter of the size memory consumption, which is very cool. This one's a little harder to explain. This is the gather time for each of the inputs. Now what we can see with the blue line here is the standard Telegraf has spikes where the gather time takes an anomaly. It takes far too long. The consistency on the BYO is greatly improved. So not only are we allocating less bytes on the heap, but our gather time for each of our plugins is drastically faster as well. Now, I'm saying drastically, we're still in the realm of milliseconds, but the consistency is better over the long term. And these ones aren't working, but these are pretty much the same. The BYO is better across the board, performance, memory consumption, and speed. So hopefully that's piqued your interest. Okay, so let's go back to our architecture diagram. Now that we have the ability to build this custom slimeline Telegraf that is super performant, we actually want to evolve this architecture slightly. And what I'm trying to get people to do is instead of running a single Telegraf in all of their nodes, is actually run 100 Telegrafs or 1,000 Telegrafs. Just keep spinning them up. And that's because we get a lot of flexibility with this approach. And that now that we're running Telegraf, you could consider this sidecars in Kubernetes. What if every pod had its own Telegraf? Now every application has the ability to determine its own metric buffer, batch size, the resolution of the metrics, and the resiliency that I want. Now if I have a very old piece of software running that is only used by 2 customers, the chances are I can have the metric buffer really low because we don't care about dropping metrics from it. Whereas stuff that is new and we're working on actively, we're going to want better metric buffer, higher resolution data. So now that Telegraf is a sidecar running next to each of these applications, we get to prioritize and decide which metrics are important to us and how those are captured. But of course, if I'm going to stand here, and, is that a question? No? Okay. If I'm going to stand here and advocate for you to take your infrastructure of 10 nodes with 10 Telegrafs and run 100 of them, then you're going to have to get really good at monitoring Telegraf too, right? You have to know when things aren't quite working as expected. So Telegraf has an internal input plugin, which will expose all of its own metrics and store them in your TSDB of choice. The ones you have to keep an eye on here are the buffer size. So that is how many metrics are stored in memory, because I want to know when it's going to hit the limit and try and predict that and then fix it before it happens. And you also want to make sure you keep an eye on the metrics dropped. If your Telegraf is dropping metrics, something has gone wrong, and you need to fix it. So I generally suggest that you keep an eye on buffer size, but alert on drop metrics. And we'll take a look at that in the demo as well. Now, this is slightly off topic, but it's one of my favorite plugins. And also, when I speak to developers, this is one of the areas that they're struggling to understand. Who's a developer in the room rather than operations? All right, cool. These are the people I'll be yelling at. Developers I speak to, when they're instrumenting their application, they're moving to Kubernetes, and they understand they have to have these probes, liveness probes, readiness probes. 9 times out of 10, this is what they call a health check. /health, it doesn't understand the application whatsoever. It has no idea if the application is healthy. It's just, if I can kind of respond to this, my app might be working, right? This is not a health check, people. This is not acceptable. Fortunately, we have our custom small Telegraf running as a sidecar next to our application. So can Telegraf help us here? And the answer is yes. Telegraf has this concept of a health output. It will create an HTTP listener for your liveness probe or readiness probe or whatever other checks you have running on your machine. And it is metric driven. So here, I'm having a health output for my application running on port 5559. You can also specify TLS if you really want to do security. We specify the name pass, which just means watch this metric. So here, I'm monitoring the web metric measurement. And I'm going to analyze the response time. So what's a really good way to understand if an application is behaving? Well, if the response time is under 300 milliseconds, we might consider that healthy. Now, this is a contrived example with a simple check. These can be more complicated. You can check multiple things. You can check multiple endpoints. You can check multiple metrics. So it's up to you to understand, if my application is returning 200s and under 300 milliseconds, it's healthy. If it's returning 200s, HTTP 200s, and over 300 milliseconds, it's maybe a warning. And if it's returning too many 500s within a 5-minute window, something's broke. That's up to you. But this plugin will allow you to analyze those metrics before it leaves Telegraf. So this all happens in memory next to your application, and you don't even need to write them to a TSDB if you don't want. Really cool plugin. And there gets to a point where scaling InfluxDB can be a little bit challenging, and we often recommend people use Kafka. The reason we suggest this is because more and more organizations are adopting Kafka anyway. So hopefully your operations team has the ability to operate and manage Kafka. But it also allows you to just, fan out those delivery pipelines. So this is the V3 architecture. I think this is definitely where we're going internally, and it's where a lot of our larger customers are going now as well. So we put Kafka in the middle of everything. We have Telegrafs at as many edge locations as possible, using the buffer and the batching, right into Kafka. We then can have a Telegraf consuming Kafka and write into one or more outputs that we want to use. What's really cool about this is that the Kafka plugin for Telegraf also supports consumer groups. We can actually scale out the consumption side of our Telegrafs depending on how many metrics per second we need to handle. The good thing about Kafka is it doesn't really, in fact, it scales pretty well horizontally, so we can write 1 million points per second on a reasonable size cluster. Doesn't mean Telegraf can consume them at that rate, so maybe we need 2, or maybe we'll need 3. And that becomes a choice that you can make, again, using the internal metric plugin to analyze how your Telegraf is performing. And I'm going to come back to this, because the demo that I've set up is this architecture. And it's going to be a little bit confusing as I work through the demo, because there are a lot of moving parts, but I'm going to try and explain it as well as I can. And serverless, right? That's another trending topic at the moment. People want to do serverless stuff. To date, Telegraf has not been possible of doing this. But fortunately, I filed a PR 2 weeks ago that adds this ability. So you can now use any serverless framework to run Telegraf configurations that run once and exit. If that's something you're interested in, I really, really would like to speak to you before I leave here. So cool, now we're going to take a look at the demo setup. Okay, let me close some stuff down. Oh, we got it. Oh, it's all too big. So we'll look at the Docker Compose file first. If anyone wants to hear my rant on why you shouldn't use Docker Compose version 3, come and speak to me afterwards too. So this is the same architecture, and I'm going to pull this back up, that we have here. So we have Telegraf Edge. So that's going to run as a sidecar. Although this is Docker Compose, just kind of think of the concept as a sidecar. And we have a special Telegraf configuration, which has a metric buffer of 50. Now, I've kept that low so that we can see it on the graph when it comes up. It's running an InfluxDB listener to support the V1 client library, which we're using in our Python application. We also support, we're also running the HTTP listener so that I can actually curl metrics to Telegraf. And one of the things that people always talk to me about at conferences is, yeah, there isn't a plugin for Telegraf to scrape this thing. And what I also want to show you here is that that shouldn't be a barrier for getting metrics from whatever archaic systems that you're working with. We also have a socket listener, which creates a Linux or Unix socket that you can just cat metrics to, literally using the cat tool, or NC. So I'm going to show you that working. We then have the health output. It's pretty much the exact same example from the code that I showed earlier, only I've got a response time of 5. There's a reason for that, and I'm going to show you it. We're doing internal metrics, so we're going to keep an eye on the buffer. We're writing to standard out, and I'm only doing this so that I can show you the multiple outputs. We're also exposing all of these metrics for Prometheus to scrape too, so we're writing to multiples. And we also have a Kafka output. Everyone's still with me? So the Edge Telegraf is writing to Kafka, Prometheus, and a file. Once it's in Kafka, we then have the Telegraf consumer, which is using the Kafka consumer plugin to read from the same topic that we're writing to. And it's writing to InfluxDB 1 and InfluxDB 2. And let's actually just pull up those metrics, make sure it's healthy. Looks good. So first, we'll take a look at InfluxDB 1. Come into the metric explorer, take a look at Telegraf, and there are my web metrics here. And let's change the window on this to be 5 minutes. So this is metrics going all the way through our pipeline and heading InfluxDB 1. I'm just showing you that so you know it's not fake, and then we're going to focus on InfluxDB 2 now. And we're going to look at the exact same metric, so we're going to go to web metrics, look at the response time, and look at 5 minutes. So you can see that we kind of have this mild oscillation of metrics, and that's me using the health output plugin to kill my Python application every time it is bad. What does that mean? Well, I'm not a very good Python developer. So somehow, through a very poor code review process, we managed to inject the sleep command. So every time someone hits this Python application, it's sleeping for 1 second. The second request, it sleeps for 2 seconds. The third request, it sleeps for 3 seconds until it hits 5 seconds, where Telegraf notices the response time has gone too high, marks it as unhealthy, and Docker restarts it. And that's the power of the health plugin here. So we're using real metrics from the application to determine if it's healthy or unhealthy, and having our orchestration, Docker Compose, or Docker, Kubernetes, restart it when we feel that it's not behaving properly. The other really cool thing about this demo, well, I think so, is that it's using InfluxDB 1 client library. And we're also writing to InfluxDB 2. So again, it's really easy to move our metrics around. Now, I also want to show off the random ways in which we can also get metrics into an application. So first, I have a script on here called tcurl. Oh, typing failure. All right. So this is using a curl command to localhost on port 8080 and send in a JSON blob. And that's it. That's me writing metrics just with a terminal and curl. We also have another script on here, which is, let's see if I can remember the name, techo, which uses echo 512, piping it through netcat to write to a Unix socket on this machine. And again, these metrics are going through that entire same metric pipeline that everything else is. So there's a really cool advantage to having these telegraphs everywhere. It doesn't matter what software you have, there's always a way to get metrics through Telegraf to your TSDB. Something else I want to show would be, is it tprom? Oh, this one I just called prom, okay. Which prom? Nope, user bin prom. There we go. So this Telegraf is also exposing all of my metrics in Prometheus exposition format. So if you want to run Prometheus there too, it could be scraping all of this as well as it going through the standard pipeline. And that allows me to do the correlations to understand that I'm watching the watchman and that my system is actually working correctly. Okay. What have I forgot? Oh, I think that's my demo. Yeah, so we're using the health output, we're using live metrics to determine if the application is healthy. It's been restarted when it fails. We're using curl, we're using netcat, and we've got a Prometheus client exposition. So Telegraf is a really powerful tool. Oh, no. I did forget something. I knew there was something. Let's kill Kafka. So I talked about resiliency, right? I want to understand that my pipeline is always going to work, even when I take away the core component in the middle. So we're going to give that a few seconds. In fact, I have to give it 10 seconds. We actually want to see some metrics get dropped here because I have a very small metric buffer of 50, and I'm writing more metrics than that every 10 seconds. So what we should see here is we have some missing metrics. So I'm going to use the internal write. So these are metrics exposed by the internal plugin from Telegraf. We have access to the metric buffer limit, the metric buffer size, and metrics dropped. So things are pretty stable until I killed Kafka. If we leave that longer, we'd start to see missing points, but I don't want to leave it too long. So I'm going to bring Kafka back up now. And what we should see is all those metrics be backfilled. We should see the metric buffer rise as they were being stored in memory, and then drop back down as Kafka came back online and flushed. We will see a small amount of metrics dropped just because I have it so low as a threshold. But you can imagine instead of 50 metric buffer limit, having 10,000, 100,000, or 1 million. It all comes down to your usage and what you're using it for. I'll turn on the auto refresh. We'll give this 5 seconds, and hopefully it kicks in. There we go. So we have a blue line here. This is the buffer size metric. As Kafka was unavailable, the buffer stuff increases, and eventually that will drop back down as the metrics come back through the screen. I'll leave that there just now, and we'll move forward. Let's go into here. So this is my custom branch of Telegraf with the run once flag. You can see here it exits when it finishes. This is our in fact, one of our oldest feature requests on the GitHub repository. It was launched in 2016. We never got around to it. I wanted it, and now it exists. So it's a really cool flag. And we've done a demo. So what I would iterate here, Telegraf is an extremely powerful tool. It can collect metrics and give you a whole bunch of flexibility with buffering, batching, and resiliency. And we've only touched on 10 of the plugins here. So there are over 200. You can imagine the amount of capabilities that we have in this tool. So hopefully you can all go play with it and let me know what you enjoy. My slides are online at SpeakerDeck. All of the code from this demo is on my GitHub, so the links are here. I am on Twitter. If you ever have any problems with any product from Influx Data, it's my job to answer those questions. So feel free to tweet me at rawcode, and I'll come and help you out. Are there any questions?
1 sec.
One. Okay, can you go back to the picture with Kafka?
Yeah, of course.
Okay, I don't understand this architecture. So all of this is very new to me, so it could be a stupid question. Anyway, if I well understood, we can have a lot of messages from the various Telegraf instances, let's say 10 million. So we handle all of them with one cluster of Kafka. What I don't understand is what happens after the cluster of Kafka, because I guess if it receives 10 million messages, it publishes 10 million messages. So how you can handle them? Is there a way to reduce the size, to map, to group?
Yes. So what I would suggest, if you're publishing to Kafka and you do have high velocity of metrics, is that you're probably going to want your compaction on that topic to be every hour, 6 hours. That's up to you, right? So the Kafka side is just there to allow us to distribute to multiple Telegrafs on the consumer side. Once the metrics hit the consumer side of Telegraf, which is the two in the top left, those can do all of the same in-memory aggregations, processing, and serializing that are available in all the Telegrafs. So even though you're writing 10 million messages, you can definitely write all 10 million of those points to InfluxDB or Prometheus or something. But if you want to work out aggregates over 5-minute windows, Telegraf can do that before writing to your TSDB. So it's just making sure that you have Kafka is there to allow you to fan out this consumption side, do the in-memory aggregations if you want them, or just control the ingestion rate to your TSDB. The thing is, TSDBs are purpose-built to handle high-velocity inserts, but people are doing some really crazy stuff with metrics. So bringing in Kafka just allows you to have a little bit of protection. And it means if something does go wrong, you can go back within your retention policy on Kafka and reconsume those metrics. Or you can write into another data store. That's up to you. So it's just there as an ability to offer up Telegraf on both sides of the pipeline.
Okay, thanks. Okay. Well, I have another question. I don't know.
Yeah, go for it.
Okay. So you said that Telegraf is resilient. If you have to write to somewhere which is not available, it uses a buffer. But what happens if it's Telegraf itself that goes down? Is this buffer persistent? Is there a way to persist it?
No.
Okay, thanks.
If Telegraf crashes, you will lose whatever's in memory.
Okay.
What a lot of people do, or what some people do, is they write to a file locally as well, and then that can be purged every 10 minutes. And it's just like a really pseudo write-ahead log. That's there as an option. Not something I would encourage, but if you really need to guarantee metrics aren't lost, it's a good way to do it.
Okay, thank you.
Yeah. Can you just throw that over? Yep.
Oh, it works. Okay, is there another broker output, just like Redis?
Yes.
Instead? Yes? Okay.
So if we pull up the code here, on the edge side, we have output Kafka here. So that's going to write all of our metrics to Kafka from Telegraf.
Only Kafka?
No, there's RabbitMQ, there's MQTT.
Redis?
Redis is one, yeah, you can use
Yes.
Redis.
Okay.
There are a lot of plugins.
Okay.
Any more questions? All right, well, thank you very much for your time. I hope you found this interesting. Please do come and speak to me at any point throughout the day. I'd love to talk to you. Thank you.